Hello there, my name is Menu Kishan. I'm a trainee software engineer of Zenith Software International. This video is about the advanced features of Android development. So, let's begin our journey. Here are some advanced Android features which we are selected to discuss due to time limits. They are system permission in Android, content sharing in Android, wearable in Android, Android TV, and location and map in Android. Let's discuss them on following slides. System permissions in Android. Why we need system permission in Android? Because to protect the system integrity and the user's privacy. Android runs each app in limited access sandbox. If the app wants to use resources or information outside its sandbox, the app has to request the permissions. Depending on the type of permission the app requests, the system may grant the permission automatically or system may ask user to grant the permission. You can find out list of normal and dangerous permission list on the developer.android.com. How we declare permissions? You have to declare it using users permission tag in Android manifest.xml as shown in the image. It should be sibling tag to application tag. The system's behavior after you declare a permission depends on how sensitive the permission is. If the permission does not affect user's privacy, the system will grant the permission automatically. If the permission might grant access to sensitive user information, the system asks users to approve the request. The next advanced feature we are going to discuss is content sharing in Android. This is how we take app interaction to the next level by sharing information with other apps. There are three ways of doing it in Android. They are sending simple data to other apps, sharing files with NFC. Let's discuss about sending simple data to other apps in more detail. There are three main ways to send simple data. First one is send text content. The most straightforward and common use of the action send action is sending text content from one activity to another. This is useful for sharing an article or website with friends via email or social networking. The second one is send binary content. Binary data is shared using action send action combined with setting the appropriate MIME type and placing URI to the data in an extra name extra stream. This is commonly used to share an image but can be used to share any type of binary content. Third one is send multiple pieces of content. To share multiple pieces of content, use the action send multiple action together with list of URI pointing to the content. The MIME type varies according to the mix of content you are sharing. For example, if you are sharing 3 JPG images, the type still is image/JPG. For mixture of images type, it should be image/star. To match an activity that handle any type of image, you should only use star/star. If you are sharing out a wide variety of types, as previously stated, it's up to the receiving application to pass and process your data. Apps often have a need to offer one or more of their files to another app. One way a sending app can share a file to respond a request from a receiving app. In all cases, the only secure way to offer a file from your app to another app is send the receiving app the file content URI and grant temporary access permission to that URI. Content URIs with temporary URI access permission are secure because they apply only to the app that receives the URI and they expire automatically. The Android file provider component provides the method getURI for file for generating a file content URI. If you want to share small amount of text or numeric data between apps, you should send them intent that contains the data. Last method of sharing is sharing files with NFC. Android allows you to transfer large files between devices using the Android Beam file transfer feature. This feature has a simple API and allows users to start the transfer process by simply touching devices. In response, Android Beam file transfer automatically copies files from one device to another and notifies the user when it's finished. While the Android Beam file transfer API handles large amount of data, the Android Beam NDEF transfer API introduced in Android 4 handles small amount of data such as URI or other small messages. As I think Android Wear is a one of coolest use of Android OS. Android Wear is Google's first dedicated smartwatch OS designed for smartwatches and other wearables. By pairing with mobile phones running Android version 4.3 or newer, Android Wear integrates Google Now technology and mobile notification into smartwatch form factor. It also adds the ability to download applications from the Google Play Store. Android Wear is based on the same Linux kernel as its smartphone. In the image you can see currently available latest Android Wears. Android TV is a smart TV platform developed by Google. Based on the Android 5 operating system or later, it creates an interactive television experience through the 10-foot user interface. You will be able to offer your apps and game in the storefront experience that optimize for TV. You can extend your new or existing apps for Android TV, then publish them using similar tools and process in Google Play. Google Play lets you put your TV apps in front of new audience of users in their living rooms. You can develop and publish using your existing developer console account and your current distribution and pricing system. One of the unique features of mobile application is location awareness. Mobile users take their devices with them everywhere, and adding location awareness to your app offers user a more contextual experience. The location API is available in Google Play services facilitate adding location awareness to your app with automated location tracking, geofencing, and activity recognition. The Google Play Services location APIs are preferred over Android Framework Location API as a way of adding location awareness to app. Well, let's see a demo about locations in Android development. First, create empty activity Android project on Android Studio. Then you can see a view similar to mine. Here we are going to show longitude and latitude on text field. Let's start it. You can see it already have a text view. You can see there is already a hello world string on it. I'm just gonna hard code it and then I'm going to give it an ID. Here we are going to write latitude of the phone to this text view. If I take a look at the design view, you can see it has already changed into the string that I entered. Location goes here. Now we have UI defined. Our Android manifest is almost done. Because we are going to use Google services, there is one meta tag we need to add. That's just for specifying that we are using Play Services library. It is meta tag and it should be sibling to application tag. Now we have to go to build.gradle for define the Play Services library that we uses. In dependency, we are going to add a new dependency for Play Services. Add your version of Play Services here. First of all, we need our activity to implement various callbacks and listeners. As you can see here, I implement Google API client connection callbacks and Google API client on connection fail listener. You can see txt output text view object here is to address text view on the main UI. Then you can see I have Google API client and location object. Now in our onCreate method we need to set Google API client and we use this with Google API client builder. What it does? It Create new builder for Google API client and add location service API. Then connection callback to come this class. Also we need on connection fail listener to come this class. Then we'll allow Google API client to use Google Play services. Next we set text view object to UI text view. Once you have connected to Google Play services and the location services API, you can get the last known location of the user's device. Here is the code to set text view to last known altitude. Now run your app and you can see your latitude on the screen.